Dr. Mohan Sharma, my co-chair, co-moderator today, Dr. Gopal Sedai, and respected sir, Dr. Achut Prasad Sharma, and all the respected seniors, namaste, and all the colleagues. Shall I start with due respects from Dr. Krishna Sharma?
Please start. Shuru karo.
Okay, so today once again.
Gopal Sedai आउनुभयो?
म छु सर, यही छु।
ए ल नमस्ते।
So we are going to start today's webinar, our online CME of NESON. So today once again we have our usual one of the very good presenter and very enthusiastic presenter, I should say. Once again, Dr. Mohan Sharma, welcome to our usual webinar series of NESON. And Dr. Sharma is very much well known for his highly philosophical presentation with lots of old sayings, histories, and African proverbs. Though at times it is confusing and sometimes difficult to understand, but most of the time it is quite interesting, simple, and highly educational. And moreover, today's topic is very, very vital topic, statistical analysis, which is backbone of any research methodology. So without any statistical analysis, the whole research becomes meaningless. Well, with this background and with the consent from my co-chair, Dr. Gopal Sedai, do you have to say anything about Professor Sharma, because you are the one, sitting and standing whole day all the time with Dr. Mohan Sharma?
No, I think it's okay, Dr. Praveen. You have already said many things. Let's start and we can discuss later on.
Okay, Professor Mohan Sharma, please go ahead with your presentation.
Okay, thank you, Dr. Praveen and Dr. Gopal, for a very kind introduction, though I don't deserve all you said. Thank you, NESON, for giving me again another platform for sharing some of my areas of interest, not only in neurosurgery but this para-neurosurgery topics. And this is also one of the core curriculums in the research methodology course we run annually in teaching hospital. And I thought this will be very pertinent for our young neurosurgery colleagues with the increasing number of publication of the articles and other things. So I have total 38 slides, and I have 6 question answer quiz questions in the very end. So we will have a quiz in the very end, and I'll briefly go through the slides, and if there are any confusion we can ask in middle or in the later part of the presentation, and the moderator will take note of the questions. So the title of my presentation today is Basic Medical Statistics for Neurosurgery. I always start with some kind of quote, and here goes this one: the deepest sin against the human mind is to believe things without evidence. This
Sir,
has
screen आएन सर, screen मा के आएन?
I know.
Slides आएन.
Oh, okay. ल यहाँ share गर्न मिलेन जस्तो लाग्यो भन्छ है. Okay, I made the mistake. यसमा my start. Namaste.
ल तयार, रेडी?
हजुर, को डाक्टर पन्त हो?
हो.
Oh, Dai, namaste. Welcome to the webinar. So, shall I start? The title of my presentation today is the Basic Medical Statistics for Neurosurgeons. This is the most fundamental thing I'm going to say. Though I declare at the outset that I am not an expert in this field, but what we found in the later part of our training and our as a teacher is that the class taken by pure statistician is too complex, because they don't have the pain of understanding the statistics from a clinical clinician's point of view. So we thought we as clinicians should be trained in medical statistics and take classes for our junior. And that's exactly what inspired me to go through this medical statistics. This is the quotation I have chosen here, which would be relevant. The deepest sin against the human mind is to believe things without evidence. So as a scientist, we should always believe with evidence, if there is evidence or not. And the best way to get evidence is getting any study which has been proven statistically correct. So in the line of this, Neurosurgery Journal has started at least one article every 2-month series, reason to believe, the biostatistics and methodology for the neurosurgeon. So from 2019, they are publishing at least one article per issue or every second issue. For example, in the January 2019 issue, they had this writing a clinical research question. Remember, we went through how to formulate a research question. If you go through this article, you will know how to exactly formulate research question. And they have a series, and the last one was published in 2020 March, and the title of the article was Comparing Effects of Treatment, Controlling and Confounding Factor. So the neurosurgeons have also to be interested in statistics is exemplified by this fact. So what is the objective of my presentation today? These are the objectives here. First and foremost is to inspire young neurosurgeons. Well, the senior one also can enjoy, but my main goal is to inspire young neurosurgeons to develop statistical thinking. That's number one. Number two is learning the essential concepts of medical statistics, which are needed for proposal writing. As young neurosurgeon or resident, we have to write proposal, we have to publish paper, and to critically appraise the medical literature also, we have to have a basic understanding of statistics. And what we don't need to know is how to do a statistical analysis. We don't really need to know how to calculate, but we need to be able to interpret this. So this is the corollary I like to put here. I don't know how to play the cricket, but I know how the score is counted. Like when somebody is out, when you score 4, when you score 6, or when somebody is stumped. So all these things I know. That's why I enjoy watching cricket. This time I missed the IPL because it is postponed indefinitely. Maybe they will not do this year. But doesn't mean that I go to the field and I bat or I ball. So this is exactly what, as a clinician, we need to know. We need to interpret the results. This is the main idea of my presentation today. So what is the definition of statistics? This is done. This is the most widely accepted definition by J.M. Lass. We remember we read this book in our MBBS days. The science and art of dealing with variation in data through collection, classification, analysis, and interpretation in such a way as to obtain the reliable results. This is what the basic definition of statistics is. And the medical statistics is, of course, the application of statistical concept in the field of medicine. This is medical statistics. This is the fundamental. Hello? पछि फोन गर्नु है मलाई 1 घण्टामा and then phone उठाइदिनु है. This is the fundamental principle of statistics. What we accept there is a chance that we will come to the wrong conclusion. Statistics never say that we are 100% right. So statistics always presumes that we can come to a wrong conclusion, but there is a way how we minimize going into that wrong conclusion. This is the fundamental principle. Let's go to the basic concept. What do you mean by population? Population is nothing but a group of people who share a common character or a binding trait, usually the disease. So we can have a population of patient with cerebral aneurysm. We can have a population of patient with cervical spinal injury. So population is a group of people who share a common binding character. And as a sample. Sample is supposed to be a representative part of that population. So it's impossible to recruit the entire population. So what we usually do is we take a representative sample, a part of that population, which is called a sample. This slide beautifully shows how this is in the target population is the population we are interested. Suppose we are interested about the cerebral aneurysm all over Nepal. That is the target population. But I cannot go all over the country and take individual cases. So what I'll be doing is that population which is accessible to me. So which is the population accessible to me is the patients who are coming to teaching hospital is accessible to me. Maybe for the nation's president, the entire population of Nepal all the hospitals and neurosurgeons working all over the country will be maybe the accessible, the sampling frame. And then from that sampling frame, I'll take a sample of the patients. And then that sample, I'll do some study, some research, and then I intend to generalize the result of that study back to the target population. So this is how the target population, sampling frame, and the sample is defined. There is subtle difference between these four terms: data, information, knowledge, and wisdom. Data is, this is how they define data. Data is a set of values making the basis of reasoning or calculation. This is data. From data, we gather information. Data has been analyzed in some fashion so that it becomes suitable for making decision once. So if we have got data, and if we analyze data, we come to a conclusion that becomes information. Third is knowledge. Knowledge is nothing but understanding based on extensive experience dealing with information on a subject. So we have multiple information on a subject, then we become knowledgeable. And ultimately we become wise, just like Buddha. How this happens is practical application of a person's knowledge in those circumstances where good may result. So from the data, your ultimate goal is to acquire wisdom. So not everybody will be able to go through this step, but our aim should always be going from data to wisdom. Let's get an example. Okay, this is the Mount Everest. You know, there was a traffic jam in Mount Everest. Climbing Mount Everest is also tough. So, but if you apply those data to wisdom philosophy, so calculating the height of Mount Everest would be acquiring the data. Then the information will be you gather other data regarding Everest climbing, the weather of the climbing, the steep, how difficult, all these things will be the information. And third, knowledge would be 1 + 2 plus an understanding based on the advice of the experienced climber. Those who have already climbed Mount Everest or similar high peak mountains, and you gather all those information. And then the ultimate wisdom would be actual successful climbing of the Everest based on 1, 2, 3. So somebody, all I know is height of the Everest, and maximum I have gone to level 2. Maybe somebody will go to level 3 and somebody will actually climb level 4. So in the field of statistics also exactly the same thing happens. Well, let's go to the distribution. Now we have defined data, knowledge, information, knowledge, and wisdom. So distribution of data is nothing but how the data is spread in the population. So it can be, it can be jumbled, or it can be skewed on the left side. It's skewed on the left side. It could be skewed on the right side. It could be all jumbled up. But sometimes it will follow a pattern that half of the population is towards one side and half of the population is on the other side. This is what is called normal distribution of data. And this is because it looks like this bell, so it is called the bell-shaped distribution of the data. This is the most fundamental part of the fundamental thing we need to know before we start analyzing the data, because unless we know how the data is spread, we will not be able to apply the right type of test. If you normally distributed data, you will apply some kind of test. If it's not normally distributed data, you will apply different kind of test. So this is the fundamental thing we need to know. Now, this is the book, and my entire presentation is based on this book. You can take the screenshot. This was written by one GP and the statistics. Dr. Harris is the general practitioner and Taylor is the statistician. And they wrote this very easy step-by-step book, Medical Statistics Made Easy. It is freely downloaded, it can be downloaded from the web, and it gives you a very step-by-step knowledge of how to know the basics of statistics. So they have divided these core topics from describing the data to analyzing clinical investigation and screening. It's about 105 pages book, and it will be very useful. I recommend all of you to go through this book. The statistics which describe data are like this: range, percentage, mean, median, mode, and standard deviation. We'll briefly go through this topic one by one. Range and percent, these are very, the star shows how commonly they are used in the literature. It is very commonly used. Range is worse in robustness. It doesn't tell you much about the distribution of the data. All it says is maximum value and minimum value, but it gives you some idea like what is the age of the patients who are infected with COVID-19 in Nepal, means from 2 months to 81 years. So all we know that okay, every age of the patient can be, no age is exempt from this disease. That's all we need. We learn from this information. And the percentage, there is a slight difference. If you know the exact value, like 80.4, you say percent. But if you are not sure what is the actual amount, then you say percentage. Like what percentage of Nepalese have spinal injury? That is the percentage and percent difference. Sometimes what the researchers do is they use percent instead of saying the true value. If their sample size is very small, like if you have a 2 patient with something, they would say 20% of the patient. So you have to, if they use percent and show some statistically significant data, then you have to ask for the original number. This is one caveat here. Mean is also very commonly used. 3-star means it is in the very commonly used in the proposal and published paper. Almost two-thirds of all the published paper use mean. So we need to know what exactly this is. It is most useful when the data are normally distributed. Half of the data should be on the other side, half of the data should be on this side. So mean will be most important in that sense. It is how we define mean is nothing but the sum of all values divided by the number of values. This is the easiest one to calculate. And but one thing is we have to watch out for the outlier. Like if there are patients maximum, the age of the patient starts from 5, 10, 15, and then majority of the patients, there is only one patient who is 90-year-old. Everybody else is below 60-year-old, and that one patient who is 90-year-old will take mean to a different level, which is not exactly true. So in those situations, what they recommend is an interquartile range. So 25 to 75% of all the numbers will be in that interquartile range. Another thing, this is one of the jokes about the statistician. If there is a river and its depth varies from place to place, at one place it is 1 feet, at another place is 6 feet, another place 10 feet. And if you take the average of the depth of the river, it will come out like 4 feet. And if the statistician wants to cross the river, he will be drowned when he reaches 10 feet depth. So we have to be very careful in using mean solely. If the mean looks a little bit odd, then we have to go way around to find out where the true value lies. So this is all about mean. Then another is the median. Median is, it is not as commonly used as mean. It is used by more than 1/3 of the paper, so we need to know it. It is used to represent the average when the data is not symmetrical. If you have asymmetrical data, just like shown in this thing, it's not normally distributed data, then median is better used compared to mean. What it is it is a point at which half of the values are above and half of the values are below. So if this is the median, then half of the value will be here and half will be here. This is the median. So if you read the literature, you will find sometimes the median is used, sometimes the mean is used. Next is the mode. Mode is not that commonly used in academic literature. It is rarely quoted in paper, and mode is the most frequently occurring event. And there are some diseases where they are multimodal fixed, like the craniopharyngioma has a bimodal distribution. In younger age, there is a peak, and then in the late adulthood, there is not much, and then after 40, and then again you have peak. But in terms of statistical analysis, mode doesn't have much value. Now we go to the standard deviation. The standard deviation is the most frequently used term, and we need to know what it means. Standard deviation is quoted in more than 50% of the mainstream papers, and it is used as a basis of a number of statistical calculations. So we need to know what standard deviation is. How we define it it is the main prerequisite is you cannot use standard deviation in non-normally distributed data. You have to have a bell-shaped curve of your data before you can use the standard deviation. What it does, it indicates how much data is spread around the mean. It's nothing but, if you have a mean and then how far the data is gone on each side. This is what is told by standard deviation. Again, it is not necessary for us as a clinician to know how to calculate, but we need to know how we interpret the standard deviation. Sometimes, when they do the data dredging or data mining, the statistician, chokes the data to get the something significant, and we need to find out how they are using the okay. Okay, so this is the chart which shows how the standard deviation is calculated. So this is the mean, half of the value lie on this side and half of the value lie on this side. So classically, this is computed. Classically, the standard deviation includes approximately 68% of the data. If something says 2 standard deviation, and it will include 95.5% of the data. And somebody includes 3 standard deviation, it will almost include 99.7% of the data. So if you say, weight is about 55, then plus minus 5, that means, they have included 68% of the data. If you go to the next slide, it will be clear. So this is the example. A group of patients enrolling for a trial had a normal distribution for weight. This is a prerequisite. The mean weight was 80 milligram. For this group, the standard deviation calculated was 5 kg. So it should be interactive actually. So the one standard deviation means 68.3% of the participant weighed between 75 to 85. See, this is 5 kg. So minus 5 plus 5. So one standard deviation means 75 to 85. 2 standard deviation, it will encompass 95.5% of the participant. They will weigh between 70 to 90 kg. And if somebody is very aggressive and wants to include 3 standard deviation, you will include almost all the participants, but the range will range from 65 to 95. So this is exactly how they use standard deviation in the literature. When they start describing about the results of any original article, this is how they start saying about the weight of the patient, height of the patient, and the age of the patient. This is important. Now let's go to the statistics which test the confidence. These are 2 terms which are very important. One is the confidence interval, another is the p-value. Okay, what is confidence? Confidence interval is also extremely popular and used in more than 3/4 of the mainstream papers. So we need to know this. What it is nothing but a range or interval in which we can be fairly confident where the true value lies if we had access to the whole population. If you take the entire population of the patient, suppose with aneurysm, and we want to know that their age, then we will be able to suppose their mean is 55 and their mean age is 55 years. But if we do not have access to the entire population of cerebral aneurysm in Nepal, and if we have the access of the patients who are from Kathmandu, then the confidence interval shows that the mean, we say how confident are we that our mean calculated by our research actually represents the mean of the entire population of Nepal. This is what the confidence interval is. Confidence interval shows how confident are we that our mean is really inside the true mean. This is what confidence interval is. And there are two things we have to be careful. Size of a confidence interval is related to the sample size. Larger studies, they want to be very sure, very robust, so they use a narrow confidence interval. But if you have a smaller sample size, then wider confidence interval will be better, because you want to encompass the true population mean in your research. So this is the thing about the confidence interval. And there is another thing is called the margin of error. You must have come across many papers where they describe about the margin of error. And this picture will demonstrate what margin of error means. So we have a population. From that population, we took a sample of the sample and we did the study. And our intention is the result of that study should eventually be applied to the population. This is what the aim of the research is anyway. But yeah, while the result of this sample is really applied to the population, there will inherently be some error in applying that result into the population, and that is called the margin of error. And it is up to the researcher how much margin of error they want to, they want to take the risk. So if it is a very risky operation, a risky thing, like drug toxicity, then you have to keep the margin of error very low, because the people can die, like hydroxychloroquine and COVID-19. You have to put the margin of error very low. But if it is a very, if some drug with whether how many patients will develop nausea or at the most one episode of vomiting, then you can keep margin of error big, no problem. Nausea doesn't kill people. So how much margin of error you put depends on what kind of risk you want to undertake. Next important thing is the p-value. This is also most commonly used thing, and we need to know what it means. It is used by more than 80% of the paper we read, so we need to know. It is used when we used to see how likely it is that a hypothesis or a null hypothesis is true. If this is what the p-value is, it gives the probability of any observed difference having happened by chance. As I said in our last this presentation, that we never prove anything. We reject the hypothesis. We don't accept any hypothesis. So p-value basically says that how much is the chance that we can be true. That is what the p-value is. How much is the chance that we can be wrong. That is what the p-value is. So it is, again, it is not important to know how the p-value is derived, calculated as a neurosurgeon, but we need to know what the p-value means. Okay, how we interpret it, this is the example. If the p-value is 0.5, there is a 50% chance that you can be right, 50% chance that you can be wrong. So it is obviously not significant. If something is 50-50, then it is in our modern medicine, it is not true. So probability of the difference having happened by chance is 0.5 in 1, 50-50. So it is not significant. Now, this is by convention. There is nothing that if there is 0.06, it is useless, or if something is 0.04, it is useful. It's not that. This is the arbitrary point they have kept statistician as 0.05. What exactly it means? The probability of the difference having happened by chance is less than 0.05. That is less than 1 in 20. What it means is we did a very beautiful research and we have calculated the p-value as 0.05, means that our result is true in 95% of the times, but we could be wrong in our conclusion in 5%. Suppose the p-value is 0.02, so we can be wrong by 2%. This is what p-value 0.05 means. And it is called, by convention, statistically significant. If we have a p-value of 0.01, difference having happened by chance is 1 in 100 times, it is called highly significant. And if somebody has a p-value of 0.001, so we say it is very highly significant. These are actually derived, these are labeled by convention. In general, anything which is less than 0.05 is considered as statistically significant for the majority of the studies. So this is an example I like to show you so that it will be clear. There is an example. 376 patients in neurosurgery OPD were randomly assigned to be seen by Dr. Jones and Dr. Smith in 1 week. Okay, so this is the chart. It shows that patient, Dr. Jones saw 200 patients, Dr. Smith saw 176 patients, and patient satisfied with consultation With Dr. Jones, 93% of the patients were satisfied, and with Dr. Smith, 95% of the patients were satisfied. And see the time they spend in doing the consultation. Dr. Jones spent on the average 3.1 minute, and Dr. Smith spends on the average 2.8 minutes. So who is better? Anybody? Just looking at this, we cannot say who is better, who sees the patient faster. It seems that, Dr. Jones finishes, 16, in 3.1 mean consultation length by Dr. Jones is 16 minutes, and by Dr. Smith is 6 minutes. It seems that Dr. Jones sees patient very slowly. He is useless to stay in the clinic. It seems like that. But unless we apply the statistical test, we cannot see for certainty whether the difference between 16 and 6 is really true or not. So let's apply the statistic, and this it shows. The p-value, in terms of satisfaction, there is no statistically significant difference between Dr. Jones and Dr. Smith. But in terms of seeing the patient faster, Dr. Smith is much faster. It's a 0.001 p-value. That is much faster. He will be liked by everybody in the clinic because he sees the patient fast, goes home. So this is, unless we apply the p-value, do some test and calculate the p-value, we cannot be sure. Okay, having said this, there is a slight difference between statistical and clinical significance. Something can come as a usually statistically significant, but it may not have any clinically significant value. For example, there is a beautiful drug marketed, developed in the market, which decreases systolic blood pressure from 180 to 175, and the statistician calculated is to be statistically significant. But if there any medicine that lowers the blood pressure by 5 millimeter mg from 180 to 175, is not clinically significant. We need this at least to be below 150. So we have to be very careful how we interpret these statistically significant results. Okay, there is now we go to statistic which test the differences. So first, but again, I repeat here also. First, we have to tabulate the data and find out whether the data are normally distributed or not. If the data are normally distributed, then you apply the parametric test. If the data are not normally distributed, then you apply the non-parametric test. This is the fundamental thing you have to find out. If you find that the data are parametric, then the test you are going to use are the t-test, Fisher's exact test, and chi-square test. If you find your baseline data to be non-parametric, then you have to use Mann-Whitney test or Kruskal-Wallis test. I will briefly go through this test, and then the presentation will be over. So t-test or student's t-test. This is William Seeley Gossett. He worked in the Guinness, the beer factory, and he was hired as a chief brewer, and he needed to find out which barley will give the best tasting beer. So he formulated a kind of test, and without going through the entire barley field, he would find out by using which type of barley he will get the best Guinness beer. This is how this t-test was developed. And that time, the Guinness brewery did not allow any of its employee to use their real name because their rival will copy the trade secret. So, with Dr. Gossett used student as a pseudonym to publish the paper, and this paper was published in 1908. And this is the background of the t-test. How it works is it is important in more than 40 papers, so it is advisable to be well versed. And it is tested only in a normally distributed data, just said. And they are typically used to compare just two sample, and it is used to determine if the means of the two sets of data are significantly different from one another or not. Let's go through this example again. We go to this the same thing, Dr. Jones and Dr. Smith in one week. So we use the p-value, we use the statistical test, in this case the student's t-test, because we are comparing the means of the two set of value. So in the conclusion one, it is likely that the H0 null hypothesis is correct. So we can reject the hypothesis, and we come to the conclusion that p-value is 0.04. We came to the conclusion there is no difference between the satisfaction level of the patient between Dr. Jones and Dr. Smith. But if you go to the second slide, second line, it is very likely 1 in 1,000 chance that the null hypothesis is correct. So we reject the So we reject the hypothesis and conclude that Dr. Jones sees patients significantly faster than Dr. Smith. This is how we apply t-test. Next is the chi-square test. This is also extremely common test used in medical literature. It is used in more than 40% of the papers. It determines if two categorical variables are related or not. See, the difference between student t-test and chi-square test is this. In student's t-test, it compares the means of the two samples. But in chi-square test, it determines if two categorical variables like yes, no question, male, female, those kind, disease plus, disease minus, those kind of things, you use the chi-square test. And typically they use the contingency table, which means this kind of 4x4 table, expose nothing. We can apply the same test like to what percentage of the healthcare workers working in the hospital have the risk of catching COVID-19. And you can use the chi-square test and exactly formulate what is the risk of them getting the disease. Okay. Next is the Fisher's exact test. This is also similar to the chi-square test. Only thing is, if your sample size is very small, then you can use Fisher's exact test instead of chi-square test. What they say is, if you do the subgroup analysis and if the number of the subgroup is less than 5, then instead of using the chi-square, you use the Fisher's exact test. Why it is called exact test is it doesn't say less than this, less than this. It gives you the exact p-value of that p-value, saying that the difference is to what extent. This is a famous Ronald Fisher and the one lady had a famous bet that the tea. They did the experiment on the taste of the tea. If you put sugar before milk or milk before sugar and find out which tea taste better. So I recommend you to go through lady tasting tea. The episode it is very interesting how and then which led to the Ronald Fisher developed this kind of test. It is very interesting. I recommend you to go through this. Okay. Now, Mann-Whitney U test is used for non-parametric test. It is not that as important as chi-square or t-test, but still it will be useful. Sometimes you have to use it. It is a non-parametric test, as already said. It is used to compare two sample means and calculate the p-value. It is just like a t-test, but for t-test, you use the parametric data. For Mann-Whitney, you use the non-parametric data. This is all we need to know. And it is usually used when the data is ordinal, like somewhat like this is called Likert scale in statistics. And for another example, which is Glasgow coma scale or Glasgow outcome scale, when there is a graded, and grading of some information, then Mann-Whitney U test is used, and data if the data is non-parametric. Then there are statistical tests which compare the risk, and for this, the commonly used is the risk, relative risk or risk ratio, which is used in cohort studies, and odds ratio, which is used in case control study. We need to find out if somebody is doing a cohort study and says that I use the odds ratio, then this is not compatible. So we need to know if you are doing cohort study, please use relative risk. If you are doing case control study, please calculate odds ratio to find the risk of developing some disease or not. Okay, and then statistics which analyze the relationship is basically done by correlation and regression. Correlation is it measures the strength of the association between two variables. Now, it could be positive variable, it could be negative. Like you can do what is the age and the outcome after drainage of the chronic subdural hematoma. We can do that, or the age of the patient and the mortality after subarachnoid hemorrhage. There are many things we can do, and what we'll be using is the correlation. And how you calculate the whether there is correlation, significant correlation or not, you do by calculating the correlation coefficient. Again, for the normally distributed data, you use Pearson's correlation coefficient, and for the non-normally distributed data, you use Spearman's correlation coefficient. This is all we need to know. Is this, as a neurosurgeon, we don't need to go beyond this. But if somebody says I am using normal, my data is normally distributed, but I am using Spearman correlation, he is not saying the right thing. There is something wrong there. So you use depending upon the nature of your data, you use the right kind of statistical tool. And after correlation comes the regression. Regression, it quantifies the association, and it should be used if one of the variable is thought to precede or cause the other. Sometimes the example given usually is rainfall versus crop yield. If there is more rainfall, then the chances of your crop yielding high will be much higher. If there is, we are also right now we are saying that because of this lockdown, the incidence of road traffic accident has gone very down. So we are saying this because we have observed, but if we really want to quantify statistically, so we will be using regression model. Okay, now this is the last part of this statistical tool. So the statistical thing which analyze survival is also very important, especially in oncology, neuro-oncology. And they do the survival analysis by using the life table and Kaplan-Meier plots. And Cox regression model is another one. So this is an example of the Kaplan-Meier plot. This is a patients with the diagnosed rheumatoid arthritis which are followed over 50 years, for example. So what it says is, over the years, the patient will eventually die of rheumatoid arthritis. So if you follow patients with rheumatoid arthritis after diagnosis, at the end of 20 years, how many? 36% of the patient will still be alive. If you follow them 30 years, so these many patients will be alive. So if you follow them 40 years, only 10% of the patient will be alive. Same thing with the glioblastoma multiforme. Same thing with anaplastic glioma. And by calculating the Kaplan-Meier curve, you can predict, and we can get the, we can explain the patients or family before surgery that what is the risk of likelihood of that particular patient surviving based on this data. If you have two sets of data, then you can again do the statistical test and find out the difference. So again, the same chart, Kaplan-Meier curve, this is for the male patient and this is for the female patients. And at the end of 20 years, females, okay, men is the break. The only 18% of the patients are surviving, 18% are surviving, whereas male, more than 44% are surviving. So whether this difference is statistically significant or not, that we have to use, and that is called log rank test. By using the log rank test, we can say whether the difference in survival between women and men is statistically significant or not. It doesn't matter which type of test you use depending upon your data, but ultimately it is the p-value that measures. By doing log rank test or t-test, chi-square test or Mann-Whitney test, you come to the p-value, and if it is less than 0.05, you consider that as statistically significant. Okay, then there are statistics which analyze clinical investigation and screening, and the one we use commonly is the sensitivity, specificity, and predictive value. And the talk of the day these days is what is the sensitivity or specificity of real-time PCR versus RDT for diagnosing COVID-19. So we need to find out what is the sensitivity. Some tests can be fantastically sensitive, but very less specific. Doesn't mean anything, It has to be more than 95% sensitive, more than 90% specific before some tests can be rolled in the market. Currently, RDT is so useless. It's so many, about 50%, specific. So 50% of the time you can be wrong. Some in India, they use this in Jaipur. They say it is sensitive only in sensitive and specific only in 5% of the cases. So, rapid diagnostic testing of this COVID-19 is scientifically considered really useless. So we need, for the RT-PCR, Some say it is more than 95%, some says 99%. Now yesterday I read another literature, it says 70%. It depends on the, how they take the sample, how they take the swab, how it is processed in the lab, whether there was any cross-contamination. So many things comes into play before we say that this test is this much sensitive or specific. So to conclude my presentation, when you have a data, we take that data and do a proper statistical analysis, and we come to some degree of evidence which can be useful in the management of our patient day to day. So the concluding quote is, statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. This was said by A.G. Wells, and this was back in 1900. So with the exponential publication of the literature and very complex analytical models and statistical tests, we all need to be well versed with the basic techniques of statistics. So this is my conclusion. Now I'd like to take you through some quiz. Hello, Dr. Praveen. Hello. I have 5 questions. You want me to go through this quiz now or after? Up to you. I have finished my presentation.
Okay. Maybe briefly we can have some comments and suggestions from our seniors.
Okay.
We can go to quiz and question answer. Will that be okay?
Okay. So
Dr. Gopal, anything you would like to say?
Very statistics is most of the times taken as a very difficult thing, and sir has tried to make it simple, though it is inadequate. It's simple, thought-provoking, so that things can be made simple, and those who are interested, they can still go for other read further, and if needed, they can take opinion from sir. And I think we should also go for the quiz which sir is asking, so that we'll know whether we have learned something or not.
Okay. Anything, Panta sir? I think you are already there. So, anything would you like to suggest or comment? Sir को mic off बस sir. Sir को mic ले unmute.
के कसो होस्टमा मात्र हुन्छ जस्तो त्यो अप्सन
हैन तलबाट
हो
हजुर पन्त सरको माइक
हेलो अब आयो
हजुर
थ्यांक यू भेरी मच डाक्टर मोहन एकदम कलेजमा हुँदाखेरिको पनि गाह्रो सधैँ गाह्रो खालको टपिकलाई तपाईले धेरै इजिली चाहिँ प्रेजेन्ट गर्दिनु भएको छ र सिनियर इन्क्लुडिङ जुनियर सबैको लागि चाहिँ आजको लेक्चर एकदम थ्यांक यू भेरी मच आई लर्न अ लट टुडे
so shall we go for the quiz?
Okay, यो चाहिँ अब रियल इभेन्टमा चाहिँ एकदम मजा आउने हो र वी युज टु गिभ प्राइज अल्सो अब अहिले चाहिँ यो चाहिँ यसको आन्सर गर्नेहरूलाई हाम्रो डाक्टर कृष्ण शर्मा नेसनको प्रेसिडेन्टले दिनुहुनेछ प्राइज है सायद भेट दशैंसम्म भेट होला नि
दशैंको पार्टीमा दिनु पर्ला
प्रवीण अब यसको आन्सर कसले भने कसरी थाहा
मलाई चाहिँ प्रवीण म चाहिँ निस्किन्छु पनि होला थ्यांक यू भेरी मच
हस् थ्यांक यू सर थ्यांक यू भेरी मच सर
ओके
बेलरमा आन्सरको लागि च्याट बक्समा नै आन्सर गर्दा सजिलो हुन्छ कि
ल ओके त त्यसमा त्यो च्याट बक्समा हेर्नु कसले करेक्ट भन्छ उलाई चाहिँ तपाई र डाक्टर गोपाल मध्येमा एकजनाले अनाउन्स गर्दिनु
हजुर हुन्छ डाक्टर गोपालले प्लिज क्यारी अप
Which of the following is the first step in starting the research? Searching the sources of information to locate the problem, survey of the related literature,
स्क्रिन भएन
ए भएन है
हजुर
ए सरी है ल पख्नु है एकैचोटी 1 सेकेन्ड है खै के भयो मेरो यसमा ह्याङ भयो जस्तो है इट्स वर्किङ है जस्ट अ सेकेन्ड ओके मैले यसबाट शेयर गर्नुपर्ने शेयर स्क्रिन है पावरपोइन्ट अहिले भयो
सेयरिङ हुन खोजेको के जस्तो लाग्छ तर आइसकेको छैन भयो सेयरिङ भयो हजुर
This is the first question. I have 6 questions. यो Dr. Krishna अलिकति यो राख्नुपर्छ है Which of the following is the first step in starting the research? Searching sources of information to locate the problem, survey of the related literature, identification of the problem, searching for solution to the problem.
Identification.
Log, Dr. Gopal, log भनेपछि log भन्नु.
Problem identification.
Time is over. जसले त्यहाँ गर्नुभयो गर्नुभयो.
तीनटा आन्सर आयो सर
Identification of the problem is the correct answer. कसको आन्सर आयो?
सी रुपेशको सी आयो सर दिनुजको बी हेमन्त शाहको सर्वे अफ द रिलेटेड लिटरेचर कुन हो सर
Identification of the problem is the correct answer.
भनेको कुन सी हो
सी
रुपेशले पायो.
सी कि बी सर
सी सी
Identification
रुपेशले पायो
ल ल
रुपेश
unless you identify the problem, you cannot do the research. The first thing is
एकदम ब्याकग्राउन्ड नोइज धेरै आइरहेको छ प्लिज
कोहीले बोलिरहेको छ.
माइक बन्द गर्नु सबैले
माइक म्युट गरिदिनुस् न प्लिज सबैले.
ल कृष्ण सर यो सेकेन्ड क्वेशन. Which one of these statistics is unaffected by outlier? Mean, interquartile range, standard deviation range. The answer please turn 10 seconds ma. Okay, lock.
एउटा मात्रै आन्सर आयो सर बी
Okay, कसले दिएको B answer?
हेमन्त शाह
Okay, I think that's the correct answer. Interquartile, if you have an extreme outlier, then you take the interquartile range, 25 to 75%. So that outliers are excluded. So interquartile range is the correct answer. Okay. Number 3, P, easy sir. P value means how likely we are certain that our data is true. How likely is that the findings are by chance, whether our sample size is adequate or not. Time starts now. Okay. Answer आयो?
आयो सर
Okay, के छ answer?
दिनुज श्रेष्ठ बी
How likely is that the findings are by chance, हैन?
हजुर सर
So P less than 0.05 भनेपछि we are less than 5% that we could be wrong by wrong, हैन? Okay, second is the correct answer.
धेरैजनाले एन्सर गर्नुभयो बी तर दिनुजले फर्स्ट गरे हुनाले दिनुज विदा विना
Dinuj Shrestha ho?
हजुर सर
From Japan. La, congratulations. La, okay, so now number 4. Easiest. Chi-square test is used for non-parametric or parametric data. Okay, log गरौँ? के छ answer?
लक गरिदिनु
ल log भयो. के छ answer?
एउटामा ए आयो सर दुईटामा बी
मनिष
आयो
प्रक्षेपति बी प्रत्युष बी नरेन्द्र बास्कोटा ए
ये भन्ने को हो?
नरेन्द्र बास्कोटा
बर्बाद. This is always for parametric, always, right? Chi-square test, t-test, Fisher's exact test, they are always for normally distributed data. Right? So parametric, please. Right? Okay, now almost close. Okay, now this is the, suppose the data are normally distributed with a mean of 120 and a standard deviation of 30. Between what values will approximately 68% of the data fall? 60 and 180, 90 and 150, 105, 135, 140, 170.
First.
One standard deviation हुँदाखेरिमा data कहाँ पर्छ? यो with example भने थिए मैले. लग गरौँ? हेलो आन्सर आयो कि रघुगोपाल
आयो सर आयो
कति
सबभन्दा सुरुमा हेमन्त शाहले बी मनिष कोलाक्सापति बी सुमन फुयाल ए हरि रूपेश असीम सालिखे बी एउटा मात्रै ए सुमन फुयाल ए
सुमन फुयालले ए कसरी भन्यो भन्नु त व्हाट वाज द र्यासनल किनभने 120 इज द मिन है र हाम्रो डेटा नर्मली डिस्ट्रिब्युटेड छ फन्डामेन्टल त त्यो भयो हैन त्यसपछि 1 स्ट्यान्डर्ड डेभिएसनमा 68% हुन्छ भनेपछि 1 स्ट्यान्डर्ड डेभिएसनमा 30 छ भने 130 minus 30 120 minus 30 120 plus 30 गर्दाखेरि जुन भ्यालु हुन्छ त्यो भ्यालु इज द करेक्ट आन्सर यसको र्यासनल चाहिँ 90 and 150 इज द करेक्ट आन्सर है
बी
Okay, this is the correct answer, right? So this is the last question for today. Ali lamo cha la. An experiment was done by randomly assigning each participant either to walk for half an hour 3 times a week or to sit quietly reading a book for half an hour 3 times a week. At the end of the year, the change in participants' blood pressure over the year was measured and the change was compared for 2 groups. This is an example of a good interventional study because of these things la.
Question आएको छैन स्क्रिनमा क्वेशन देखिएन हजुर पुरानै 5 नम्बर क्वेशन छ 6 नम्बर क्वेशन आएन
है
आएन
यो 5 भयो है अब 6 नम्बर आयो
आएको छैन
यसमा त आयो अरूहरुकोमा छ कि छैन
मेरोमा चाहिँ आएको छैन अरूकोमा छ डटको छ बल्ल
अब
Okay la. So this is the question, long question sir. An experiment was done by randomly assigning each party. एउटा ग्रुपलाई चाहिँ आधा घण्टा दिन 3 times a week हिन्ने एउटा चाहिँ आधा घण्टा 3 times a week बुक पढ्ने 1 वर्षसम्म. So वर्षको अन्तिममा चाहिँ ब्लड प्रेसर हेर्यो. This is an example of good interventional study because of which of the following? The time starts now. ओके कति 5-6 वटा जति आन्सर आइसक्यो हैन
आइसक्यो सर
ल लक गरौँ है त ल लक्ड ल कसको आन्सर छ
अली अफी उपमा सालिखे असीम गुरुङ मनिष कोलाक्सापति सुमन फुयाल नरेन्द्र बास्कोटा सी हेमन्त शाह बी
Hemant, 2 groups were compared at the end of the study. The participants were randomly assigned to either walk or read. The beauty of any well-executed trial experiment is random allocation into either group. The biggest, this thing, hydroxychloroquine in COVID-19, unless you have a placebo or 2 group and you randomly assign, you will not come with a good conclusion. So out of all these options, 3 is the correct answer. So I think majority got the right answer. Only few got confused.
Outliers.
Outliers. So this is the end of the quiz presentation. Thank you very much.
Thank you, sir.
Thank you very much, Professor Mohan Sharma. It was really interesting and brainstorming presentation today. Dr. Gopal, ali question liu. Tapale question हेर्नु भएको छ?
मैले question हेरे Dr. प्रत्युषको question छ सर एउटा. Could we discuss the test to see if sample is normally distributed or not?
There is no test. No test. Actually, you have to tabulate all the data and find out whether it is normally distributed or not. You have to have a mean. Half of the way will be the mean. The most frequent, half of the data will be below that number and half of the data will be above that number. You have to tabulate, but computer will help you to tabulate. That's the one thing. But you have to find out by entering every individual data. So there is no test that whether it is normally distributed or not. You cannot do that. But you can use the computer to find out. That's one thing. Did I answer correctly?
Okay, sir. There is another question.
कम्प्युटरमा एन्टर गरेको चाहिँ त्यो के टेस्ट गरेर चाहिँ निकाल्दै सर मैले त्यो राम्ररी नबुझे भएर हुन के चाहिँ हुन्छ तर
हैन यस्तो छ सपोज हामीले 100 जना पेशेन्ट विथ स्पाइनल कर्ड इन्जुरीको स्टडी गर्ने विचार गर्यौं र हामीले चाहिँ उनीहरुको एज डिस्ट्रिब्युसन कस्तो रहेछ भनेर गर्न खोज्यो भने दे एन्टर द एज अफ द इन्डिभिजुअल पेशेन्ट लाइक 100 पेशेन्ट को and then you enter that the computer will if you go to the stat1 or any software that will immediately tell you whether the data is normally distributed or not. त्यसलाई कुनै स्पेशल टेस्टको नाम छैन तर they will say, but you can also do manually also. If it is like if you have sample of 42 patients, you can see immediately whether it is normally distributed or not. यसमा मेन हाम्रो फन्डामेन्टल नै नर्मली डिस्ट्रिब्युटेड हो कि हैन, हामी चाहिँ यता थानकोटतिर जाने हो कि यता बनेपातिर जाने हो, मेन नै हामीले त्यही छुटाउनु नर्मली डिस्ट्रिब्युटेड छ कि छैन, यसमा मेन जिस नै त्यही हो.
There is another question, sir. Thank you, sir, for nice presentation. Dr. Satish, resident from Bangladesh. He wants to know the difference between correlation and regression, and when should be regression be used, and what is the importance of it?
Very good question. Time नभएर मैले अघि नभनेको is a very good question. Correlation र correlation टेस्टले चाहिँ दुईटा भेरिएबल को एउटा भेरिएबल सपोज एज एन्ड द आउटकम अथवा चाहिँ जीसीएस एज प्रेजेन्टेसन एन्ड आउटकम को इट सेज रिलेसन मात्र भन्छ हैन, बट इट डजन्ट से व्हिच इज बिफोर व्हिच इज आफ्टर. टु थिंग्स आर जस्ट कोरिलेटेड हैन. गड्याङ गुडुङ भयो भने पानी पर्छ भन्न सकिदैन. नर्मली चाहिँ गड्याङ गुडुङ पछि पानी पर्छ, तर रिग्रेसनमा इफ देयर इज ए थन्डर विल बी फलोड बाइ रेन भन्ने किसिमले हेर्ने हो भने we need to apply regression. तर कहिलेकाहीँ पहिला पानी पसेर पछि थन्डर पनि आउन सक्छ. कोरिलेसनले देयर इज सम डिग्री अफ रिलेशनशिप बिट्विन थन्डर एन्ड द रेन भन्छ भने रिग्रेसनले थन्डर कम्स बिफोर रेन इन द मेजोरिटी अफ द टाइम भनेर भन्छ. सो डिफरेन्स बिट्विन कोरिलेसन रिग्रेसन यही हो.
क्वेशन्स हरु त्यति नै थियो सर.
ओके, ठीक छ. अलराइट.
Any other suggestions from Dr. Krishna Sharma?
Thank you very much, Mohan sir. Such a it was no difference whether I was in the classroom or here. Hazurle ekdam simplify with ekdam bujhne, I mean very clear examples. I really could learn a lot of things. I'm sure everybody else did the same thing. Thank you very much, sir. Thank you very much.
And question aru aaya sir Dinus ko.
Dinus.
How much sample size is enough to generalize the result for entire population for rare conditions or diseases?
Okay. अब यो sample size calculation को छुट्टै नै एउटा entire presentation हुन्छ हैन. अब यसमा चाहिँ के भन्छ भने कुनै पनि मिनिमम कुनै पनि स्टडीको लागि 30 भन्दा कम चाहिँ लिनु हुँदैन भन्छ. इन जनरल ले एनी नम्बर अफ स्याम्पल लेस देन 30 इज टेक्निकली नट जनरलाइजेबल. 30 भयो भने बेल सेपेटमा जान सक्छ भनेर नर्मली डिस्ट्रिब्युटेड हुन सक्छ भनेर भन्छ. तर इन्डिभिजुअल तिम्रो चाहिँ पावर अफ द स्टडी भन्ने हुन्छ. दिनु सुनेको छ कि छैन हैन, यु मस्ट हैव हर्ड. सुनेछौ है. यसमा चाहिँ अब जेनरली चाहिँ हाम्रो जेनरल स्टडीमा चाहिँ पावर 80% पावर राखेर स्टडी गरे हुन्छ है. जस्तो एपिडेमियोलोजिकल स्टडी हाम्रो जुन क्लिनिकल जुन गरे हुन्छ नि हामीले आउटकम स्टडीहरु 80% पावर भनेको 0.8 राखेर गरे हुन्छौं. त्यो भएर चाहिँ सपोज 50 आउँछ भने कुनै कुनैमा वी वान्ट टु बी भेरी रबर हाइली पावर स्टडी 90% पावर राखेर गरे भने त्यो 500 स्याम्पल साइज 5000 पुग्न सक्छ. सो व्हाट पावर अफ द स्टडी यु वान्ट, त्यसले गर्दाखेरि चाहिँ तपाईको चाहिँ स्याम्पल साइज फरक हुन्छ. जति पावर बढी राखे उति तपाईको कन्क्लुजन रोबस्ट हुन्छ, कसैले च्यालेन्ज गर्न गाह्रो हुन्छ. जति तपाईको स्याम्पल साइज कम राख्नुहुन्छ त्यति तपाईको पावर अफ द स्टडी विल बी लेस बट स्टिल मेथोडोलोजिकली करेक्ट हुन चाहिँ हुन्छ. तर तपाईको पावर अफ द स्टडी अस्ति एकचोटी स्टेफन फाउचीले कुरा गरे नि रेमसेडिभिरमा, पहिला चाहिँ चाइनामा गरेको थियो तर त्यसको पावर अफ द स्टडी वाज लेस. सो आई क्यान नट से दैट हाम्रो चाहिँ स्टडी चाहिँ रेमसेडिभिरको चाहिँ मोर पावर छ भने एक्ज्याक्टली त्यही हो. यिनीहरूले कति बढी स्याम्पल साइज लिएको थियो जस्तो लाग्छ मलाई यो ड्याट भनेर. त्यो भएर स्याम्पल साइज कुनमा कति लिने भने इन जनरल लेस देन 30 भयो भने त्यो ओभियसली नट इनफ स्याम्पल साइज. त्योभन्दा बढी कति लिने भन्नेमा तपाईले पावर कति राखेर गर्नुहुन्छ त्यो अनुसार डिसाइड हुन्छ.
हजुर, मैले पर्टिकुलरली अलिकति सोध्न खोजेको चाहिँ कहिलेकाहीँ हाम्रो अलि रेयर एन्टिटी अथवा रेयर प्रोसिजरहरुमा चाहिँ हाम्रो स्याम्पल साइज अलिक कमै हुन्छ नि सर। अब त्यस्तोलाई स्ट्याटिस्टिकली सिग्निफिकेन्ट कतिखेर मान्ने त भन्ने हो।
त्यो मान्न सकिँदैन। त्यो रियर भयो भने द्याट इज द भेरी रिजन वाइ वी निड टु डु मल्टी सेन्टर स्टडिज, मल्टिनेसनल स्टडिज। एक ठाउँबाट भएको पेसेन्टले स्याम्पल पुग्दैन भनेर मल्टी सेन्टर गर्ने हो। तर थोरै स्याम्पल लिएर मिनिमम नभएसम्म त स्ट्याटिस्टिकल टेस्ट अप्लाई गर्ने पाइँदैन नि। त्यो भएको हुनाले त्यो चाहिँ इन्कन्क्लुसिभ हुन्छ। त्यसले चाहिँ हाइपोथेसिस जेनेरेट गर्न सक्छ, ओके हाम्रो इन्स्टिट्युटमा यस्तो यस्तो केस पनि हामी म्यानेज गरेको छौँ है भनेर जेनरल अवेरनेस क्रिएट गर्ने बाहेक त्यसले साइन्टिफिक कन्टेन्ट चाहिँ खास दिँदैन। त्यही भएर हामीले मल्टी सेन्टर ट्रायलै गर्नुपर्छ जस्तो रियर केसहरू।
हजुर सर, थ्याङ्क यू सर।
थ्याङ्क यू कृष्ण सर फर गिभिङ मी द अपर्च्युनिटी है। हाम्रो इन्ट्यासको हाम्रो लक्ष्मणजीलाई पनि म धन्यवाद दिन चाहन्छु। यो अनइन्टरप्टेड यो जुमको अर्कै मजा हुँदो रहेछ।
Thank you very much. Thank you, Mohan sir. Thank you, Intas, and thank you all the friends. हाम्रो Saturday we'll meet again at 4 o'clock for Gopal sir ko presentation ko लागि. It will be on aneurysm. You'll get the detail about the topics and the speakers and the moderators. Stay safe and be happy. Thank you very much. Bye bye.
Thank you very much, everybody. Thank you very much. Namaste.
Hello, sir. Namaste.
Namaste, Prakash ji. Namaste.
Namaste, sir.
Yes.